In this video, I'm going to demonstrate how to apply quotient rule for differentiations. When do we apply the quotient rule? When you have the unknown, in this case x, in both of your numerator and also denominator. That's when you apply the quotient rule. For example, we have the numerator as u, we take the denominator as v. It will be u over v for this example. When you differentiate these fractions, the formula goes with v squared as the denominator. In this case, 2x plus 1 squared. When you differentiate these fractions, 2x plus 1 squared, followed by v, put it down, and then u prime. That's a prime, meaning it's a differentiated version of u. U is square root x. Change it to 1 over 2 as the power. When you differentiate u, the power of 1 over 2, you're going to bring down as coefficient, and then you minus 1 for the power. Right? I repeat one more time. 1 over 2, you bring it down, times it, minus 1 for the power. So that is your u prime. U prime. So this one, you're going to bring down here. What else? Subtraction. U. Okay? So for assert x and x power 1 over 2, go for x power 1 over 2 for easier factorization later on. V prime, this is your v. When you differentiate it, the answer will be 2, right? So here's your first step. Your first step is always to assign everything into the right place. Then followed by second step is where you need to apply factorization for the numerator. Let's do a quick recap on factorization. We take this as example, x power 5 plus x power 2. When you factorize it, what is the highest common factor? Right, x power 2. When you take out x power 2 from x power 5, what is left? What does it mean by factorize, taking out? It's the same as division. So imagine this as if like x power 5 divided by x power 2. What happened? What happened? It will be the answer x power 3. So this will be x power 3. In short, you have 5 minus 2 equals to 3, right? Subtraction for the power. So you have 5 minus 2 equals to 3. That is very important. Please take note of this later on. Followed by x squared divided by x squared, that will be 1. So plus 1. That's how you do the factorization, right? Okay, now I want you to pay attention on the numerator part. Compare the first part to the second part. Is there any common factor? Right. X. That's a common factor of x. However, this x and the other x with a different power, just like this case. So what is the highest common factor? You always take out the one with a smaller power, right? So in between negative 1 over 2 and 1 over 2, which one has a smaller power? This one. So you're going to take out the power of negative 1 over 2. Am I right? Just like this. So what you do here is you're going to take out x to the power of negative 1 over 2. Okay, what happened when we take something out? This is the original. And I'm going to take out exactly the same thing. So x power negative 1 over 2 divided by x power negative 1 over 2. What is left is just 1. Do you agree with me? Okay. But how about this part? When you have x power 1 over 2 divided by x power negative 1 over 2. What is left? You see, if I have x power 1 over 2 divided by x power negative 1 over 2, I told you, right? When you take out something, you factorize it, something is the same as division. You have 5 minus 2 equals to 3. So same thing. 1 over 2 minus negative 1 over 2. So you have x power 1. So when you factorize this part, what is left is just x power 1, right? So this is what happened when you factorize both of these by x power negative 1 over 2. You have 1 here, you have x here. Cool. What else can we take out? What else can we take out? Okay. We can also take out the 1 over 2 and also 2. Both are constant, right? So between 1 over 2 and 2, which one is a smaller value? 1 over 2, right? Highest common factor. So you're going to take out 1 over 2. 1 over 2 divided by 1 over 2, you have 1 left, right? 2 divided by 1 over 2, you have 4. Okay? Anything else to take out? Any highest common factor to take out? No more, right? Can I take out 2x plus 1? No, because you don't have 2x plus 1 over here, or multiple of 2x plus 1. So, you take out this one, you take out this one, and then you put a big bracket for whatever is left. Okay, let's check and see. So for the first part, whatever is left is 2x plus 1 times 1 times 1. Anything else? No more. So just 2x plus 1 followed by minus. On the second part, whatever left is 4x. So you have 4x. So that's how you do the factorizations. Okay? Now the denominator, nothing happened on the denominator, so just keep it the way it is. Okay, now you got the second part, second step covered. You factorize it beautifully. So what else can we do? First, this part, can we simplify it? Yes, collect the like terms. It will be 1 minus 2x and then 1 over 2. Keep it here for a while. Later on, see what we can do. Negative power, advisable to bring it down, turn it to a positive index. So it's x of 1 over 2, but I'm not going to write as 1 over 2. I'm going to keep as square root x. 2x plus 1 square. Okay, can I leave this as a final answer? No, because you have a fractions in another fractions. It's considered as not the simplest version. So how do I get rid of this denominator? Multiply by 2. So to make it balance, you need to do it on both parts. So the final answer would be here. No more, no more. Do I need to multiply 2 on this? No, you don't have to. Just have to multiply to one of them, right? Because this is not plus minus. So final answer, 1 minus 2x. Okay, without the bracket, nothing else really. 1 minus 2x over square root x bracket 2x plus 1 square. Final answer. Okay? Now I'm going to show you more examples by utilizing quotient rule. Now let's have a look on the second example, followed by the same formula. U over V. Alright, so when you differentiate this, V square V square followed by V. Let's change this one to something else, shall we? So v is the same as set 1 minus 2x. You can change it to 1 minus 2x power 1 over 2. Okay, so this is v. Followed by u prime. This is your u. What happened when you differentiate x? Right, it's just 1 minus u followed by v prime. This is the v. Let's differentiate it. One over 2, bring it in front, minus 1 for the power. And remember, this is a chain rule. You need to differentiate whatever inside here as well, right? So when you differentiate 1 minus 2x is negative 2. So one by one. So first, 1 over 2, bring it down. Followed by differentiate inside, negative 2. Followed by minus 1 for the power. So 1 minus 2x, negative 1 over 2. Okay, simplify. Never mind. I simplify later on. So this is v prime. So 1 over 2, negative 2, 1 minus 2x power 1 minus negative 1 over 2. Okay. So first step done. Now the second step is always to do a factorization on the numerator. But before that, I can simplify this. So it's just negative 1. Okay, 1 is not important. It doesn't change anything. Compare the first part and the second part. Any common factor? Right. We have 1 minus 2x. We have 1 minus 2x. Again, 1 over 2 and negative 1 over 2. Which one to be taken out? The smaller power. So 1 minus 2x power negative 1 over 2. Again, from here, you take out this one, is division. So 1 over 2 minus negative 1 over 2, since it's a division. So the answer is 1, the power is 1. So when you factorize this, then it will be 1 minus 2x power 1. Okay? When you factorize this will be 1. Because the exact same thing, right? You take out the exact same thing. Anything else we can take out? Nothing. No more, right? No more common factor. So we look at the first part. What is left? 1 minus 2x power 1. So this one is 1. Didn't change anything. So it's just 1 minus 2x. Okay, what level is left? You have 1 minus 2x. From here, minus. Okay, for the second part, I have 1 times negative 1. So still negative 1 times x. So it's a negative x. Close bracket. So that's how we do on the numerator part, right? Okay. Denominator part, a square root with a square cancel each other. So what is left is 1 minus 2x. Okay, this is a bit special, yeah? Okay, later on, we can simplify this part. 1 minus 2x plus x. What do we have? 1 minus 2x plus x, then we will have 1 minus x. Okay, do you realize there's something special about this now? Can we do something about this? Why? It's the same factor. This is negative 1 over 2. This is 1. In between them is division. So again, negative 1 over 2 minus 1. Because if I imagine it, is the same as 1 minus 2x power negative 1 over 2 divided by 1 minus 2x power 1. So in between the power, it is minus. So what do you get? You have 1 minus 2x negative 3 over 2. Am I right? And you combine these two. So now your final answer should be 1 minus 2x to the power of negative 3 over 2. Once you combine these two, again, negative power, I don't like it. I'm going to assign and put it back as a positive power, bring it down as a denominator. When I bring it down, this will be positive. So this is the final answer. Okay, now let's look into more examples now. Let's try out for more examples. Alright, so U over V first we start with V square, square of this, followed by V. Let's change this to, change the square root to power of 1 over 2. Followed by U prime, differentiate U, 2x minus, followed by minus U. So just x squared, and V prime, this is the V, differentiate it, bring it down, 1 over 2, differentiate inside, 2x, don't forget to minus 1 for the power, okay, put it in, okay, so we got a first step covered, assigning everything in the right place. Before we do factorization on the numerator, let's simplify this part. Okay, identify common factor, factorize it, smaller power, negative 1 over 2. Okay, let's do the factorization. This divided by this, 1 over 2 minus negative 1 over 2 equals to 1. So the power will be 1. So when I factorize this, it will be x squared plus 2 power 1. Okay? This divided by this, same thing, divided by itself. Everything will be just 1. Okay? Any other common factor? X. So you cannot just cancel it off, but to take it out. Okay? So take out, put it in front. When you take out, this will be 1. This will be 1. No more common factor. Whatever left, put it in. For the first part, I have 1, I have 2, so we just do 2x squared plus 4. Okay. Minus 1 times 1 times 1 times x squared, so just x squared. Square root, square, cancel off each other. Nice. Okay. Simplify this part. X squared plus 4. Okay. X. So still x. Can we combine these two? Yes. Same factor. So this divided by this. Negative 1 over 2 minus 1. X squared plus 2 negative 3 over 2. Again, let's turn this a positive index. Break it down. 3 over 2. Final answer. Okay. Last example. U over V. V squared followed by V followed by U prime. Let's do a little bit of differentiation. 5 bracket x followed by 1 over 2. So it's just 5x to the power of 1 over 2. When I differentiate, 1 over 2 times 5 minus 1, 5 over 2 x power negative 1 over 2. So put it here. Okay. Followed by minus u, so u v prime 3 plus x differentiate 1, right, from here 1. Okay, first step done. Now let's work on the second step. Second step, before we factorize, anything we can do? Not really, except this is not important. Okay, now let's do the factorization. X, okay, take it out. X, smaller power, negative 1 over 2. Okay, let's take it out, huh? X power negative 1 over 2 divided by x power negative 1 over 2, 1. X 1 over 2 divided by x power negative 1 over 2, so it's minus 1 over 2 minus negative 1 over 2, so it's 1. X power 1. Anything else? 5 over 2 and 5. So between 5 over 2 and 5, the smaller one would be 5 over 2. So I take out 5 over 2. This divided by this, 1. 5 divided by 5 over 2, what do we have? 2. Okay, any other common factor? No, huh? Okay, what is left? 1 times 1 times 3 plus x. 3 plus x minus 2 times x power 1, 2x. Okay, nothing. 2x. Denominator, keep remaining, nothing you can do. Okay, now simplify it. First, this is the part. What do we have? 3 minus x. Okay. This one, can you combine? No, you can't combine. So this one, bring down, make it positive index. 1 over 2 is the same as square root x. And then I have 5 over 2. Is this a final answer? No. You have a fraction in another fractions. So it's considered as not the simplest version. One more step. How do we get rid of this? Times 2. Make it balance for top and bottom. Gone. Do we have the times 2 for this? No. It's not plus and minus, it's just multiply. Just one of them. So final answer, 5 bracket 3 minus x over, that's a 2 here, because it times 2. 2 third x bracket 3 plus x power 2. That's your final answer. Okay, thank you.